Welcome to Day 13 of Wisdom Academy AI, my incredible wizards. I'm Anastasia, your super thrilled AI guide, and I'm absolutely buzzing with excitement today. Have you ever wondered how AI can classify things, like deciding if an email is spam or not, with magical accuracy? We're about to master logistic regression, a powerful classification technique, and it's going to be an unforgettable journey. You won't want to miss a second of this adventure, so let's get started. I've brought my best friend to say hello.
Hi, I'm Sophia, and I'm so excited to be here with you. Logistic regression is perfect for classifying data, and I've got a magical demo coming up to show you how it works. Let's dive into this adventure together.
Let's take a quick trip back to Day 12, where we had a blast exploring linear regression. We learned that linear regression predicts numbers with magic, helping us forecast values like house prices. It fits a line to the data using the equation y cot y mx plus b, finding the best relationship between variables. We explored its assumptions like linearity and evaluated it with metrics like MSE and R-squared for accuracy. We also tackled challenges like outliers with smart solutions to keep our model strong. We saw predictions in action with a fantastic demo. Now let's switch gears to classification with logistic regression. I'm so excited. Today, we're diving into the enchanting world of logistic regression, and I can't wait to explore this with you. We'll uncover what logistic regression is, the classification magic that lets AI predict categories like yes or no answers. We'll learn how it works by predicting categories instead of numbers, using some cool math concepts. We'll dive into key ideas like the sigmoid function, odds, and probability, which make it all possible. Plus, we'll evaluate it and build a model with a magical demo to see it in action. Let's classify data with AI wizardry. This journey will spark your curiosity, I promise. Logistic regression is our star today, and I'm so excited to share its magic. It's a supervised machine learning algorithm designed specifically for classification tasks, not regression, despite its name. It predicts categories like yes or no, true or false, or 0 and 1, making decisions clear and simple. For example, it can classify emails as spam or not spam, helping us filter our inbox effectively. It uses probability to decide which category an item belongs to, making it super intuitive. Despite its name, it's all about classification, not predicting numbers like linear regression. This makes it a magical tool for binary outcomes. I'm so thrilled to dive deeper. Why use logistic regression? Let's find out. I'm so thrilled to share its benefits. It's simple and interpretable, making it perfect for classification tasks, especially for beginners starting out. It works wonderfully for binary classification problems, where we need to choose between two categories. It's fast to train and easy to understand, saving us time while delivering clear results. For example, it can predict if a customer will buy a product, helping businesses target their marketing. It also gives probabilities, not just yes or no answers, adding depth to our predictions. Logistic regression is a foundational spell for classification magic. I'm so excited to explore it. Let's uncover how logistic regression works, and I'm so excited to break it down. It starts with a linear equation, similar to linear regression, combining predictors to form a base model. Then it applies the sigmoid function, which transforms the output into probabilities between 0 and 1, perfect for classification. These probabilities represent the likelihood of a category, like spam or not spam, making decisions easier. We use a threshold, often 0.5, to decide the final category, If above, it's yes. If below, it's no. The model optimizes using maximum likelihood estimation to find the best fit for the data. It's a magical process for yes-no decisions. I'm so thrilled to see it in action. The sigmoid function is the heart of logistic regression, and I'm so eager to share how it works. It maps any value to a range between 0 and 1, making it perfect for probabilities in classification tasks. The equation is 1 over 1 plus e to the negative z, where z is the linear equation from our predictors. The output is a probability, which we use to decide the category of an item, like spam or not. For example, a probability of 0.7 might classify an email as spam if our threshold is 0.5, giving a clear decision. This function shapes the magic of logistic regression, turning numbers into probabilities. It's a key ingredient in our AI spell. I love its elegance. Let's look at a magical example. Classifying email spam with logistic regression. We use data where email features, like specific words or the sender, predict if it's spam or not, labeling it accordingly. Logistic regression calculates the probability of an email being spam based on these features, giving us a clear score. For example, a probability of 0.9 would classify the email as spam, using a threshold like 0.5 for the decision. This helps filter emails with AI magic, keeping our inboxes clean and organized. It protects us from unwanted messages, making our digital life easier. This is a practical spell we all need. I'm so excited to see its impact. Odds and log odds are key concepts in logistic regression, and I'm so thrilled to share them. Odds are the probability of yes divided by the probability of no, giving a ratio of likelihood. For example, a 0.75 probability of spam means odds of 3 to 1, meaning it's 3 times more likely to be spam. Log odds are the natural log of the odds, transforming the ratio into a linear scale for modeling. The linear equation in logistic regression predicts these log odds, which the sigmoid function then converts to probabilities. This process connects linear math to classification magic, making predictions possible. It's a fascinating step in our AI journey. I'm so excited to understand it. Let's compare binary and multi-class logistic regression, and I'm so thrilled to explain the difference. Binary logistic regression handles 2 categories, like classifying emails as spam or not spam, keeping it simple. Multi-class logistic regression deals with more than 2 categories, such as classifying animals as cat, dog, or bird, expanding our options. It uses techniques like one versus rest, where it breaks the problem into multiple binary classifications for each category. For example, we can classify images of animals into multiple labels, identifying them accurately. This extends the magic to more categories, making it incredibly useful. Logistic regression is a versatile tool for complex classification. I love its flexibility. Here's a magical example of multi-class logistic regression that I'm so excited to share. We use data where animal features like size and color predict the species, cat, dog, or bird, based on patterns. Logistic regression predicts probabilities for each category, giving us a score for cat, dog, and bird. It uses a one versus rest approach, creating 3 binary models, one for each class, and combines their results. For example, an animal might have a 0.6 probability of being a cat, 0.3 for dog, and 0.1 for bird, so we classify it as a cat. This classifies based on the highest probability, ensuring accurate labeling. It's a magical way to handle multiple classes. I'm so thrilled by its power. Evaluating logistic regression models is so important, and I'm so eager to share how we do it. We use metrics like accuracy, precision, and recall to measure how well our model classifies data correctly. A confusion matrix shows true positives, false negatives, and other outcomes, giving us a detailed view of performance. We also use the ROC curve and AUC to evaluate how well the model handles probabilities across thresholds. Accuracy alone isn't enough. We need to dig deeper to understand misclassifications and improve. These metrics ensure our classification magic shines, confirming our model's reliability. Let's measure our spell's success. I'm so excited to see the results. Accuracy, precision, and recall are key metrics, and I'm so excited to explain them. Accuracy is the number of correct predictions divided by total predictions, showing overall performance. Precision measures correct positive predictions out of all predicted positives, ensuring we're not over-labeling. Recall is the correct positives out of all actual positives, ensuring we catch most of the true cases. For example, in a spam filter, we balance precision and recall to avoid missing spam while not flagging good emails. These are key metrics for our classification magic, helping us evaluate thoroughly. They help us fine-tune our AI spell. I love their clarity. The confusion matrix is a powerful tool, and I'm so thrilled to share how it works. It's a matrix that compares true versus predicted classifications, showing where our model succeeds or fails. True positives, or TP, are the correctly predicted yes cases, like correctly identifying spam emails. False negatives, or FN, are the missed yes predictions, where we failed to catch a spam email, for example. True negatives and false positives complete the matrix, covering all outcomes of our predictions. This visualizes where our magic needs tweaking, highlighting errors to improve. It's a powerful tool for classification insights. I'm so excited to use it. The ROC curve and AUC are magical metrics, and I'm so thrilled to share how they work. The ROC curve plots the true positive rate against the false positive rate, showing how well our model distinguishes classes. AUC, or area under the curve, ranges from 0 to 1, with a higher value meaning better probability predictions across thresholds. For example, an AUC of 0.9 indicates an excellent model, capable of separating spam from non-spam effectively. This measures how well our magic separates classes, giving us confidence in our predictions. It's a magical way to evaluate performance. I'm so excited to see its insights. Logistic regression has challenges, but I'm so determined to tackle them. It assumes a linear decision boundary, which isn't always true if the data has complex patterns, requiring other models. It's sensitive to imbalanced datasets, like when we have way more no's than yeses, skewing predictions. Multicollinearity, where predictors are too correlated, can affect how we interpret their importance in the model. It can also overfit if we use too many predictors, making the model too complex for new data. We'll tackle these with magical solutions to ensure accuracy. Let's keep our classification spell strong. I'm so excited to solve these issues. Let's overcome logistic regression challenges, and I'm so thrilled to share these fixes. First, check the decision boundary with visualizations, like scatter plots, to ensure it's linear enough for our model. Balance datasets by oversampling the minority class. undersampling the majority, or using SMOTE to create synthetic data points. Use feature selection to reduce multicollinearity, picking only the most relevant predictors to avoid overlap. Apply regularization techniques like L1 or L2 to prevent overfitting by keeping the model simpler and more general. These are magical fixes for a better classification spell, improving our accuracy. Let's make our model even stronger. I'm so excited to apply these solutions. Logistic regression has amazing real-world applications, and I'm so inspired to share them. In business, it can predict customer churn, determining if a customer will leave, yes or no, helping retain them. In healthcare, it diagnoses diseases, classifying patients as having a disease or not, aiding medical decisions. In marketing, it predicts ad click-through rates, helping optimize campaigns for better engagement. In finance, it assesses credit risk, predicting if a borrower will default or not, guiding lending decisions. Logistic regression is a versatile spell for classification tasks, making a difference everywhere. It impacts many fields with AI magic. I'm so thrilled by its reach. Before we dive into our magical logistic regression demo, let's get ready like true wizards. Ensure Python and Scikit-learn are installed. Run pip install Scikit-learn if you haven't yet, to have your tools ready for action. Use the customers.churn.csv dataset with age, income, purchases, and churn, or create it now with the script we've shared in the description. Launch Jupyter Notebook by typing Jupyter Notebook in your terminal, opening your coding spellbook for the demo. Get ready to classify customer churn like a wizard, predicting who will leave. This demo will bring our magic to life. I'm so excited for this. Now, wizards, it's time for a magical demo that'll leave you spellbound. Logistic regression in action. Sophia will use Python and the Scikit-learn library to classify customer churn, predicting whether customers will leave, yes or no, with AI magic. This demo will take our dataset and build a model to make these classifications, bringing the theory to life before our eyes. It's pure magic, and I can't wait to see it unfold. This will be a spellbinding experience. Over to you, Sophia, to cast this spell.
Hi, I'm Sophia, your demo wizard for Wisdom Academy AI, and I'm so excited to cast this spell. I'm using Python and Scikit-learn to apply logistic regression on a customer dataset with age, income, purchases, and churn, classifying who will leave. I split the data, train the model, and predict churn. Look, an accuracy of 85%, a great result. The magic of AI classification power is alive. Let's see the accuracy of our predictions. Back to you, Anastasia, with a big smile.
Wow, Sophia, that demo was pure magic. I'm so impressed by your skills. Let's break down how it worked for our wizards to understand the process. Sophia used Python and Scikit-learn to build a logistic regression model on a customer dataset, predicting churn with precision. She loaded and split the dataset into training and testing sets, trained the model on the training data, then predicted churn, and evaluated the accuracy. 85%. This process brings logistic regression magic to life, showing how we can classify data effectively. It shows how classification becomes real with AI. I love how this makes it so tangible. Here are some tips for using logistic regression, and I'm so thrilled to share my wizard wisdom. Start with binary classification for simplicity, as it's easier to grasp when you're just beginning with AI. Check for balanced data before training, ensuring you have enough yes and no examples to avoid bias. Use visualizations, like scatter plots, to understand the decision boundaries and confirm the model's fit. Experiment with regularization, like L1 or L2, to avoid overfitting and keep your model generalizable. Keep practicing to perfect your magic, as hands-on experience is key. These tips will make you a classification wizard. I'm so excited for your progress. Let's recap day 13, which has been a magical journey from start to finish. Logistic regression is a powerful tool that classifies data with magic, helping us predict categories like yes or no. It uses the sigmoid function to turn linear equations into probabilities for making yes-no decisions accurately. We learn to evaluate it with metrics like accuracy, precision, recall, and the ROC curve, ensuring strong performance. We also tackled challenges like imbalanced data with smart solutions to keep our model effective. Your task: build a logistic regression model using Python and share your accuracy in the comments. I can't wait to see your magic. Visit wisdomacademy.ai for more resources to continue the journey. Let's keep mastering AI together. I'm so proud of you. That's a wrap for day 13, my amazing wizards. I'm Anastasia, and I'm so grateful for your magical presence on this journey. I hope you loved learning about logistic regression as much as I did. You're truly a wizard for making it this far, and I'm so proud of your progress in AI. If this lesson sparked joy, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll dive into decision trees for classification. I can't wait to see you there for more magic. Sophia, any final words?
Hi, I'm Sophia, and I had a blast showing you logistic regression. Day 14 will be even more magical with decision trees, so don't miss it, wizards. See you soon.